chemical kinetics. So what is meant by chemical kinetics? So majorly these chemical kinetics deals with the rates of chemical reactions. See here, so the rates of chemical reactions means how fast a chemical reaction occur, how fast that chemical reactions is going on. So that should be discussed in this chemical kinetics. So while studying this chemical kinetics, so it is very much helpful to understand the mechanism of the reactions. So where the reactants are converted into products. So if you understand the chemical kinetics, then only you can easily understand the mechanism of the reactions. So it is observed that some reactions occur within a fraction of seconds. Yes, you know that in your general life, some of the reactions are in a fraction of seconds. So they're undergoing, and it will give its respective products. So some other reactions. So if you observe some of the reactions, so that will takes more than 1 day, 2 days, 3 days, or 1 month, 1 year, or years. So like that. So depending upon the nature of the reactants and nature of the reaction conditions. So all those things you can observe in your daily lives. That means if you observe these type of reactions, so in any reactions, within a time limited, they will give the products. So some other will give in a fraction of seconds, they will give the products. Some other, it will give the products in a year. So like that. So depending upon the speed of the reactions, so majorly we can classify it into 3 types. So if you observe this one, the first one is the very slow reactions. Very slow reactions. The best example for this reaction is rusting of iron. So rusting of iron, it's a very slow reaction. So it may take days to month or a year together to undergo in the complete change. As you can see that if you keep any iron in an atmosphere, so after some years, usually it can rust. So that means the rusting of iron will take months or years to convert as a complete change. So that means it can take a very long time. So that is why these type of reactions are called as slow reactions. So coming to the second one, so that is reactions within a medium speed. So there are some reactions so that will undergo in a medium speed, and then it will give the products. So the best example for this digestion of food. So the digestion of food usually it takes 3 to 4 hours. So that means it is a medium speed. And the next one, so that is fast reactions, very fast reactions. So that is third one. So the best example for this type of reaction, it is the formation of a white precipitate of a silver chloride. So that is the best example of the fast reactions. So what is the reactions when you add silver nitrate to the hydrogen chloride, or the solution which is containing the chloride ions, then automatically it will give a white precipitate. So that is known as the silver chloride. Within a fraction of second, it will give the silver chloride compound. So that is why it is a very, very fast reactions. So these are the some reactions so that depending upon the time taken the reactions. So how many very slow reactions, moderate reactions, and very fast reactions. So majorly these three types of reactions so that we have in general. So here the reaction rate, a rate of the reaction. So rate of the reaction, we're going to define the rate of the reactions. So here rate of the reaction, it will give the information about the change in the concentration of the reactants or products with the time. How the change in the concentration of a reactants or products. So that information it will give. What is the rate of the reaction? So rate of the reaction means it will give the information about the change in the concentration of the reactants or products within a time, with the time. Yes, we know that if you observe the any reaction, for example, this is the reaction A to P means A is the reactant. So B here it is the product. So the reaction is going on in this process. What happened? A it converts. That means A it will convert the P as a product. That means the concentration of the A gradually decreases. At the same time, the concentration of the products it is gradually increases with the time. Is it clear? That is why the rate of the reaction it will be the change in the concentration of the reactants or products with the time. So that is known as the reaction rate. So rate of the reaction is equal to change in the concentration by changing the time. So for example, see this one A to B, A it is the reactants. So B is products. Then how can you write the in a mathematical expression? See this one here it is a rate. How can you write it as delta A by delta T? See here, rate is equal to change in the concentration of reactants. That means we are writing the rate expression with respect to the see this one. This is the reactants with respect to the reactants. So that is a delta A by delta T. Here it is a minus. So delta A means the change in the concentration with the period of delta T. Okay. Here it is a minus sign. See this one. This is a sign. Here minus sign indicate the decreasing. See this. The concentration decreasing. We will give the information about the decreasing. See, the minus means decreasing the concentration. On the other hand, if you want to write the rate expression with respect to the product, then how can I write this? See this. The rate is equal to change in the products. Here the products means B. So delta P by delta T. So rate is equal to delta A by delta T. Yes. So delta B means the change in the concentration B with time delta T. Then finally, you can write it the rate expressions. So you see this on the K is equal to dx by dt. Dx means the change in the concentration of products reactants by change with the time. So that is you can write it as K is equal to dx by dt. This is the rate expressions of the rate of the reactions. So formula. This is the formula for the rate of the reaction. So dx means yes, we know that change in the concentration. Dt means time taken for the change. K means reaction rate. So what are the units for the rate? Yes, if you observe the formula, what is that? K is equal to dx by dt. That dx means here it is a concentration. T means it is a time. Is it clear? Dt means time. So what are the concentration by time? What are the units for the concentration? So it is moles per liter. Yes, we know moles per liter by what is the units for the time? So that is second. Then how can we write it as mole? So take it upside liter inverse, and also here it is second inverse. So simple. So what is the units for the rate? So rate units for the rates mole, liter inverse, second inverse. So see this here it is a mole, liter inverse, minutes inverse. In an hour, mole, liter inverse, hour inverse. So these are the units for the rate. And the rate law. So what is the rate law? The mathematical relationship between the rate of the reaction and the concentration of the reactants or product. That is known as the rate law. Rate law means the rate law will give the what is the relationship which is present in between the rate of the reactions and the concentration of the reactants or products. So that is known as the rate law. That means the rate of the reaction it is directly proportional to concentration C. So the rate of the reaction, the rate law. And here it is what happened. The rate of the reaction it is directly proportional to the concentration of each reactant products rise to the power. That means the rate it is directly proportional to the concentration of the reactants or concentration of the products. So the rate it is directly proportional to the products are directly proportional to the reactants. Is it clear? So if you want to remove the proportionality, then we can write a concentration that is a rate is equal to some constant, a rate constant that is K. Then concentration of products are concentration of reactants. So if you observe these reactions, here it is a let it M, here it is the N. So these are the reactants. So they will give the products. So how can you write the rate law? The rate law would have the form given by this. The rate is proportional to the concentration of the reactants or concentration of the products. So here we are writing this with respect to the concentration of the reactant. So the rate is equal to K, rate constant, concentration of A, this means A power M, and B. These are the reactants. So this what is concentration of B power M. So this way you can write the rate law for any reactions. So here N means the powers of the A, or it is known as the orders for each reactants. K means, yes, we know that is known as rate constants. So this is about the rate law. So now, so factors influence the reaction rate. So there are some factors so that are influence on the rate of the reactions. So if you change that factors, then how can that factors affects on the rate of the reactions? So let's see. So here, chemical reaction process at different rate, and the rate of the chemical reaction can be varied, changing in the reaction condition. If you change the reaction condition, it's automatically change the reaction rate or rate of the reactions. So here is some factors. So let's see one by one. That is effect of concentration. effect of concentration of the reactants. That means if you change the concentration of the reactants, so then what happened to the reaction rate? So here, the rate of the reaction is, yes, we know that the rate of the reaction is depending upon the concentration of the reactants. Yes, we know that in the previous slides, we know that rate of the reaction is directly proportional to the concentration of the reactants and products. Yes. So based on that, here also the rate of the reaction depends on the concentration of the reaction. So that means what? Then automatically the rate of the reaction increases with increasing in the concentration of the reactants. If you decrease the concentration of the reactants, then what happens to the rate of the reaction? So it is automatically decreasing in the rate of the reaction. So that means you can write it as the concentration. So here the see this one, the concentration of the reactants, it is directly proportional to the rate of the reaction. Yes, yes. That means if you increase the concentration of the reaction, they will automatically increasing in the rate of reaction. If you decrease the concentration of the reactants, yes, automatically decreasing in the rate of the reaction. So that is why you can write the formula for the this one, that is effect of concentration of reactants. So that means what? Concentration of rate, it is directly proportional to the rate. And the second one, the effect of temperature. Then how this factor affects on the reaction rates? Yes, the rate of chemical reaction here, it is the increasing with the increasing in the temperature. So there are some reactions. If you increase the temperature of the reaction condition, then automatically the reaction goes very fast. Fast means the reaction rate. Rate of the reaction means is nothing but speed. Rate means speed. If you increase the temperature, then what happened to the rate of the reaction of that specific reactions? So it is automatically increasing the rate of reactions. So that means, and approximately the rate constant becomes, since the rate constant becomes double for a rise in 10 degrees Celsius. If you increase the 10 degrees Celsius of any reaction, then automatically the rate of the reaction will become double. That means very, very fast at 10 degrees Celsius. See this. Then how can you write it as? Simply, you can remember that one, that is temperature. It is also directly proportional to the rate of the reaction. See this. Yes. Temperature, it is directly proportional to the rate of the reaction. That means if you increase the temperature, then what happened to the rate of the reaction? There is also increasing in the rate of the reaction. So next one, effect of pressure. So effect of pressure. So how pressure affects on the rate of the reaction. So let's see here. The effect of pressure on the rate of the reaction occurring in condenser. So in condensed phase it will be negligible. That means in the liquid solution and solids, there is no talking about the pressure. Okay, so that is why we neglecting the pressure factor in this conditions. So that means liquid, solution, and solids. Whereas the reaction, so occurring in a gaseous phase, see this one, in a gaseous phase, the increasing in the pressure, increasing in the rate of the reaction. See this. If you increase the pressure of the reaction, the reaction where it occurs in a gaseous phase, if you increase, then what happened to the rate of the reaction? The rate of the reaction is also increases. So then how can we write it as in a short form? The pressure, it is directly proportional to the rate of the reaction. See this one. So if you increase the pressure of the reaction, then it's automatically increasing in the rate. Yes, if you decrease the pressure of the reaction conditions, then it is automatically in the decreasing in the rate of the reactions. So that is why we are writing the final, the pressure is directly proportional to the rate. Okay. So the next one, the effect of catalyst. See this one, effect of catalyst. Catalyst means it is a chemical substance. When you add the catalyst to the any reaction, then what happens? What is the behavior of the catalyst? The catalyst, it will not involving in the reaction, but affects on the rate of the reaction. So for example, there is a reaction. Yes, we want the products in a fast manner. Then what do you have to do? You have to increase the rate of the reaction. So in that condition, if you add a chemical substance, so that chemical substance having capacity to the increasing in the rate of the reaction, but it is do not involving in the reaction. See this. In that case, what happens if you add the catalyst to that reaction, the rate increases and products getting the very fast. Yes. So in other hand, there is a reaction. That reaction undergo very fast, but we don't need that much of speed. So in that case, also we are adding some chemical substance to that reaction. So that chemical substance will slow down that reaction. So in the both the case, we are adding a chemical substance that will have a capacity to the effects on the rate of the reaction. That means a chemical substance that will be capacity to the increasing the rate of the reaction, that will have the increasing capacity. And also in the other hand, it can decrease the rate of the reactions. That is known as the catalyst. So here the rate of such chemical reactions increasing in process suitable characteristics. For example, the rate of the reaction of a potassium permanganate. The potassium permanganate with the auxiliary ion increase. The reaction is increased when you add the magnesium ions. When you add the magnesium ions, whatever the reaction between potassium permanganate and auxiliary ion, that will increases. So another example, see, so the decomposition of the potassium chloride. The decomposition of the potassium chloride is accelerated. The presence of manganese at least. If you add the manganese reaction, the decomposition process of the potassium chloride will increase. So finally, you can say that catalyst is also affects on the rate of the reaction. So that it will increase the rate of the reaction and decrease the rate of the reactions. So that is known as catalyst, effect of catalyst. The next one, so that is effects of radiation. The effect of radiations. So the rate of a certain chemical reactions is rate of certain chemical reactions may be enhanced by the radiation. The radiation energy means the energy derived from the electromagnetic radiations. So there are different type of radiations are there. So for example, the visible and ultra, infrared, and X-ray, microwave, etc. So depending upon the reaction condition, so we are using the any one of these radiation, visible, ultraviolet, infrared. Means there are some reactions so that will undergo only in the visible conditions, or they are will undergo in the ultraviolet. or it is X-rays or infrared. So like that means finally we can say that the rate of the reaction is also depends on the radiations. Radiation also affects on the rate of the reactions. So for example, if we see this on this, the reaction between the hydrogen and the chlorine to give the HCl, to give the HCl in presence of sunlight. The reaction between the hydrogen and chlorine to give the HCl in presence of sunlight is an example of the effect of radiation on the reaction rate. Obviously, if you observe this reaction, hydrogen, chlorine, so the reaction occurs in the presence of sunlight. So these are the some factors so that affects on the rate of the reactions. So what are they? So once again, the effect of concentration. Concentration is also directly proportional to the rate. And next one, temperature. Temperature increases, rate of the reaction also increases. Pressure. Pressure also. If you increase the pressure of reaction, then automatically reaction rate also increases. Catalyst. Catalyst also affects on the rate of the reaction. So radiation. So radiation also affects on the rate of the reaction. If you increase the energy of the radiations, then automatically increasing in the rate of the reactions. So these are the some factors. So the next one, reaction order of the reaction. So what is mean by order of reaction or reaction order? See this one. The order of reaction with respect to the reactant is the exponent of its concentration terms in rate expressions. Order of the reaction means, so the order of the reaction, so here it says with respect to a reactants, with respect to the reactants is the exponential exponent, it's the exponent of its concentration terms in the rate expressions. That means order of the reaction means sum of, simply you can say it as the sum of exponential values, exponents values of the reactants in a rate reactions. So that is known as order of the reactions or reaction order. Reaction order means the sum of exponent values of reactants in a reaction rate expressions. So that is known as order of the reactions. So for example, if you see this one reaction, so MA plus NB gives rise to products. So if you write a rate expression for this reaction, it will look like this one. Let's see this one. Rate is equal to K, and that means it's constant. Concentration of the A and concentration of the B power M. See this. What is the order of the reaction? Here the sum of exponent or sum of powers of reactants in a rate expressions. That is known as order of the reaction. That means M plus N is the M plus N. These are the powers of the reactants. So that is why we are writing the M plus N. These are known as order of the reaction. That means M is the order with respect to the A. N means N is the order with respect to B. So like this, we define the order of the reaction. And also this order of the reactions, not only in a numbers, so like 1, 2, 3, it is also 0, 6, it is also 0, or it is a fractions, it is also negative. So that means finally we can say that the order must be determined by the expert. Then this order, the order of the reaction will give the which information. While knowing the order of the reaction, then what is the use? What is the use of this order of the reaction? Here also some examples. See this one. These are some examples. The total reaction order is the sum of the exponent, all the concentration terms. See this one. The total order become it is m plus n plus p. If you want to write the what is the order of the A, the A only, then m it is the order of the reaction with respect to the A. With respect to B, what is that order? That is n. Yes. See the P. The total order it is m plus n plus p. Okay. Okay. Then what is the use? So what is the use of reaction order or order of reaction? So order of the reaction will give the information about rate of the reaction. Since information will give the rate of the reaction, which is depending upon the how many concentration of the reactants. Okay. The action order of the reaction will give the information about the rate of the reaction. The rate of the reaction. Yes, we know that the rate of the reaction it is depending upon the concentration of the reactants. So majorly, how many reactant concentrations? How many reactants concentration that are actually affects on the rate of affects to the rate of the reaction. For example, so there is a one reaction. The reaction, for example, this one, this is A plus B and it gives rise to B products. See this one. If you observe this reaction simply, the rate of the reaction is the rate of the reaction means the speed of the reaction. It is only depending upon A, which see this one. If you change the concentration of the A, then it will be automatically affects on the rate of the reaction. If you change the B, that will not affects on the rate of the reaction. That means the rate of the reaction, it is only depending upon the concentration of this A only. So that type of order, it is known as first order reaction. If the rate of the reaction, it is depending upon the only one system. But depending upon the only one reactance concentration, then that type of reaction it is known as first order reaction. So there is a reaction system. For example, here this is the reaction. The reaction is only depends upon the concentration, A concentration only. Then it is known as first order reaction. Yes, there is a reaction. There is a one reaction. A plus B gives rise to products. If you change the concentration of the A, it is automatically there is a change in the rate of the reaction. And also, if you change the concentration of the B, that is also affects the rate of the reaction. So in that case, the rate of the reaction, it is depending upon the two reactants concentration. Then that type of reaction, it is known as second order reaction. That type of reaction is known as second order reaction. If it is depends upon three concepts, three, then it is known as third order reaction. If it is four, fourth order reaction. If it is zero, since the rate of the reaction is will not depending upon the any concentrations of the reactants. So that type of reaction it is known as zero order reaction. Order of the reaction is order of the reaction will give the information about the what type of reaction that is. Whether it is the first order reaction, second order reaction, third order reactions. Third order reaction means the rate of the reaction is depending upon only one concentration of the reactants. If it is two, then second order reaction. If it is three, third order reaction. If it is four, fourth order reaction. If it is not depending upon the concentration of the any reactants, so then it is zero order reaction. Zero order reaction. So how many types of reactions are there? Zero order reaction, first order reaction, second order reactions, third order reactions. So like that. N order reactions. So like that. So here the order of the reactions. So here the order of the reaction it is only determined experimentally. Remember this one. Experimentally, then only we can find out the order of the reaction. See this. So this is about the order of the reaction. So once again, recollecting all the data. Chemical kinetics means it deals with the rate of the chemical reactions. So that means how fast the chemical reactions occur. So depending upon the rate of the rate, and that means speed of the reactions. So we have majorly three types of reactions. A very slow reactions. So best example for that reaction of iron. Moderate reactions. So best example for this some of the laboratory reactions or digestion of food. And very fast reactions. Best example for the corpuscle silver chloride from silver nitrate plus HCl or chloride solution. And rate of the reaction. So rate of the reaction means the change in the concentration of the reactants or products with the time. So that is known as the rate of the reaction. So rate of the reaction you can express with respect to A, that means the reactants. So delta A by delta T, delta means change in the concentration change. Delta means change. Here negative means we give the decrease in the concentration. So that is why we have mentioned the negative sign. Respected to products, there is a no sign. Rate is equal to delta P by delta T. So finally, we can write the rate expressions for the any reaction. So that is dx by dt is equal to k. So this is the right expression. Dx means change in the concentration, dt means time change, and keep the rate constant. And units, what are the units for the rate? Yes, we know that rate means dx by dt, dx means concentration, which means time. What are the units for the concentration? Moles per liter, and time is second. So that is why moles liter inverse, second inverse, and rate law. Rate law means it will only give the relationship between the reaction and concentration of the reactants. And finally, we can write the rate is equal to K into concentration of the reactants. And here it is some factors so that affects on the rate of the reactions, effect of concentration and temperature, and the pressure and catalysts and radiations. and order of the reaction. So finally, order of the reaction means it will give the information about the what type of that reaction, whether it is the first order, second order, third order, or zero order. So order of the reaction is the sum of exponent values of the reactants. So that's known as order of the reactions.